Hello everyone, welcome back to IGCSE Science Academy. Today we are going to make science simple and easy to understand. Moving on to our topic for today, composition of soil and crop growth. This lesson is part of the IGCSE Environmental Management course syllabus code 0680. We are looking specifically at unit land, focusing on section 2.1 soil and crop growth. On this slide, we have our specific learning objectives for the day. Under syllabus reference 2.1, we have two main goals. This picture of the syllabus has been taken from the IGCSE and O Level's official website. So according to learning objectives, we have two main goals. First, we will learn how to describe the composition of soils, what exactly is soil made of. Second, we will explore why that composition is so important for crop growth. We will also notice reference to SDG 2 and 15. These are the United Nations Sustainable Development Goals for zero hunger and life on land, which shows just how vital this topic is for our planet. A detailed video for SDG Sustainable Development Goals, which are 17 goals, has been uploaded in the channel. You can watch from there. Let's get into the details of learning objectives. Here are the learning objectives what we will cover today. Defining the fundamental composition of soils, analyzing how soil components directly affect crop growth, connecting land health to global goals SDGs, zero hunger and life on land. Now let's start with the basics. What is soil? Think of soil as much more than just dirt. It is actually the top layer of earth that we work on. Its most important job is that it supports plant growth by providing a home for roots and essential nutrients. But where does it come from? This is the question. This is the main question, that but where does the soil come from? It is a mixture of two main things, weathered rocks and organic matters. What are the weathered rocks? They are tiny fragments of rock broken down over thousands of years. What are organic matters? This includes decayed plants and tiny organisms. Essentially, it is the bridge between the geology of our planet and the life that grows on. What is soil made of? The four main components which make this soil. First is mineral particles. The concentration of mineral particles is 45%. The mineral particles are silt, sand, and clay derived from weathered rocks. Organic matters, which are 5%, humus made of decaying plants and organisms. Water, 25%, found in the spaces between particles essential for nutrient transport. Air, 25%, provides oxygen for root respiration in soil organisms. These are the four main components which combinedly make the soil. Now that we know what soil is and how soil is made of, let's look at why it matters on global scale through the United Nations Sustainable Development Goals. The global context SDG 2 and 15. SDG 2, that is zero hunger. Remember how we said soil supports plant growth. Without healthy nutrient-rich soil, we can't grow enough food to feed the world's population. It is the very foundation of food security. Healthy soil is the foundation of food security. Without nutrients-rich land, we cannot feed a growing population. So, second, SDG 15, life on land. This goal focuses on protecting our ecosystems. By using sustainable soil management, we prevent and land degradation and desertification. How does this relate to our previous slide, or how this relates to the soil and the composition of the soil and the particles of the soil? If the weathered rocks and organic matters we just talked about are destroyed or washed away, the soil can no longer support life. To reach these global goals, we must protect the composition of the soil we just studied. Here are the main components of soil as we have discussed: mineral particles, organic matter, humus, water, and air. These are the four main particles, four main components of soil. Now let's discuss about mineral particles. Mineral particles are sand, which are large particles, silt, which are medium particles, and clay, very small particles. Let's discuss each mineral particle one by one. Let's look at the first major component of soil, sand. Sand has the largest particles, as you can see in the picture, largest particles of all soil types, and that size dictates how it behaves. Good drainage. Because the particles are large, as you can see in the picture, there are big gaps between them. This allows water to flow through very quickly, preventing the soil from getting waterlogged. Second is feels gritty. If you rub sandy soil between your fingers, it feels rough and scratchy. This is what we call gritty. And third is low nutrient retention. The downside to their quick drainage is that water washes away the nutrients and that plants need to grow. Sand is a great for air and water movement but poor at holding onto plant food. Now let's look at silt, which you can think of as the middle child of soil particles. Medium-sized particles, silt particles are smaller than sand but larger than clay. As you can see in the picture, feels smooth. Unlike the grittiness of sand, silt has a smooth, almost floor-like feel when it's dry. When wet, it feels slippery. Moderate drainage. Because the particles are medium-sized, it offers a balance. It drains better than clay but holds water longer than sand. Hold water and nutrients. It is quite fertile because it can retain enough moisture and nutrients for plants to access. Suitable for crops. Because of this balance, silty soils are excellent for growing a wide variety of crops. Finally, we have clay, which sits at the opposite end of the spectrum from sand. Smallest soil particles. These particles are so tiny you can't see them individually because they are so small. They pack together very tightly. As you can see in the picture, feels sticky when wet. If you add water to clay, it becomes very sticky and can be molded into shapes. Poor drainage. Because the particles are so tightly packed, there is very little space for water to move through. This is why clay can easily become waterlogged, meaning it holds too much water. High nutrients retention. On the positive side, clay is exactly at holding onto water and nutrients, making it very fertile if managed correctly. So while sand drains too fast and silt is the balance, clay holds onto everything, sometimes a bit too well. Let's look at this visual comparison of the different particles. As we can see, soil is rarely just one thing, it is a mixture of layers and particle size. Gravel. At the top we see gravel. These are the largest, heaviest pieces. Sand, silt and clay. Moving down, we can see the clear difference in texture and color between sand, silt and clay. Notice how the clay particles look much more compact and dense compared to the loose, grainy sand. Organic soil. At the very bottom, we see the dark organic soil. Remember from our earlier slide that this is made from decayed matter which provides the essential nutrients for crop growth. Seeing them together like this help us understand why good mix of these, often called loam, is usually best for farming. It combines the drainage of sand, the nutrient retention of clay and the richness of organic matter. Now we reached a very important part of the soil, organic matter, often called humus. Unlike the rock particles we just talked about, sand, silt, and clay, humus comes from life. It is made up of decayed plants and animals that have broken down over time. There are two main reasons why this is vital for our crops: rich in nutrients and improve soil fertility. Rich in nutrients, as these organic materials decompose, they release the essential minerals and food that plants need to grow strong. Improve soil fertility. It acts like a sponge, helping the soil hold onto moisture and creating a better structure for roots to separate. Essentially, if sand, silt, and clay are the house for the plant, organic matter is the refrigerator full of food. Let's talk about a component that is literally the lifeblood of the soil, that is soil water. Water is not just there to keep the soil wet, it performs three critical functions for plant. Contain dissolved minerals. Soil water acts as a solvent. It dissolves the nutrients found in humus and rock particles so that plants can actually drink them in. Needed for nutrient transport. Once those minerals are dissolved, water is the vehicle that carries them from the soil through the roots and up into the rest of the plant, essential for photosynthesis. Finally, water is a raw ingredient. Without it, plants cannot perform photosynthesis to create their own energy and grow. Think of soil water as the delivery system. Without it, all those great nutrients we just talked about would stay stuck in the ground. As you can see the picture, this is the soil water picture, and this picture shows that how much water is important for the soil. So we cannot forget what fills the empty spaces between soil particles, that is soil air. Just like us, the living parts of the soil need to breathe. Provide oxygen to roots. Plant roots are living tissues that require a steady supply of oxygen from the air pockets in the soil to stay healthy and grow. Needed for respiration, this oxygen is essential for the process of respiration, which allows the plant to convert stored energy into growth. Support microorganisms. Healthy soil is full of tiny beneficial organisms like bacteria and fungi. These microorganisms need air to survive so they can continue breaking down organic matter into nutrients for our crops. So while water is the delivery system, air is the energy system that keeps the whole underground environment alive. Now that we have looked at all the individual parts, the sand, silt, clay, air, water, and humus, let's see why the overall composition is so important. The balance of these parts matter for three main reasons. Affects crop yield. If the soil is too sandy or too clay heavy, plants won't grow as well. The right mix ensures farmers get the most food possible from their land. Control water retention. The composition determines if water stays near the roots or drains away. As we saw, sand drains fast while clay holds it tight. Getting this balance right prevents both drying out and waterlogging. Supplies nutrients. A healthy composition ensures there is enough organic matter in water to dissolve and deliver minerals to the plants. Ensure the soil composition is the recipe for a healthy environment. If the recipe is wrong, the plants can't survive. Now let's discuss about humus and crop growth. We have seen what humus is, but let's look specifically at how it helps our crops grow. There are three major benefits. First one is aids nutrients. As we mentioned, humus is like a natural fertilizer. It slowly releases essential minerals into the soil for plants to absorb over time. Improves structure. Humus helps bind tiny soil particles together into small clumps called aggregates. This creates a crumbly texture that makes it much easier for roots to push through the soil and grow deep. Increase water holding. Because humus is organic, it acts like a sponge. It can hold several times its own weight in water, which keeps the soil moist even during dry period. So whether it's providing food, making the ground easier to grow in, or saving water, humus is a farmer best friend. So after looking at all these different components, what does the perfect environment for a plant actually look like? Most farmers and gardeners aim for what we call ideal soil. It's loamy soil. This is the Goldilocks of soil. It is a perfect mix of sand, silt and clay. This mixture ensures you get the drainage of sand but the moisture and nutrient retention of clay. Rich in humus. As we just learned, having plenty of organic matter is essential for feeding the plants and maintaining a healthy soil structure. Well aerated, moist. Finally, the ideal soil must have the right balance of air pockets for roots to breathe and enough water to transport nutrients. When you have these three things working together, you have the best possible foundation for high crop yield and healthy plants. Here is the comparison of sand, silt and clay. Soil particle sand, size of particle in millimeters 0.02 to 2.0 millimeter. The texture is gritty. The characteristics drains water quickly, large air spaces, very low water and nutrient retention. Soil particle silt, the size of this particle is 0.002 to 0.02 millimeter. The texture is smooth and silky. Its moderate drainage holds some water and nutrients, fairly fertile. Third one is clay, which is less than 0.002 millimeter. Its texture is sticky when wet, hard when dry. Poor drainage, very small air spaces, high water and nutrient retention. To wrap everything up for today's topic, let's review the key points from today's lesson. Four main components. Remember that soil is a complex mixture of minerals, sand, silt and clay, organic matter, humus, water and air. Supports plant growth. Each of these components play a vital role from providing physical support and nutrients to ensure the plant can breathe and stay hydrated. Balanced soil equals healthy crop. For the best farming results, we need a balanced, ideal soil like loam combines these elements to create the perfect environment for the crops to thrive. Understanding these basics is the first step toward better environmental management and global food security. That's bring us to the end of our session today on soil and crop growth. I hope this gave you a clear understanding of the foundation of our environment. Don't forget to go over your notes on the four soil components and the importance of humus. Make sure you are familiar with the syllabus requirements for the upcoming examination. Thank you for your time and focus today at the IGCSE Science Academy. Keep studying hard and I'll see you in the next lesson.